Hello, everyone. Thank you once again for joining us. It's great to see you all here. I've just got a couple of things to mention. It's going to be a little bit variable over the next couple of weeks, and definitely next Friday. Many of us are actually going to be traveling to The Hague for a couple of kind of working sprints at Canonical, where we do a bit of a retrospective on the previous 6 months and also some planning for the following 6 months. And we'll be trying to take the Canonical Open Documentation Academy to the next level as part of that. It's a really big part of our plans, and also looking at what we're doing here. And I think we'd really like to try and improve the quality of what we're doing and the diversity in what we're doing. So if you've got any comments on these sessions or the Academy in general, please let us know. Message me directly or in the forum or on Matrix. We really appreciate the feedback, and we've been overwhelmed by the positive messages we've had from people interacting with the Academy and through here as well. So this session won't happen next Friday, but on the weekend next week, which is, I don't know, I think it's the 29th, it's Saturday the 26th, sorry. It's Friday the 25th, Saturday the 26th, and Sunday the 27th. There's an Ubuntu summit in The Hague, just outside of Amsterdam, and we are going to have a documentation booth. Those of us at Canonical who have volunteered to do it. So if you're in The Hague and you want to come along, it's free to register. For the sessions, actually, they're broadcast online. Broadcast, is that still a thing? And you can register for that for free as well. We'd love to meet you if you happen to be in The Hague. It's at the World Conference Centre. But on the evening in Netherlands time, which I think is going to be about 16:30 Universal time, so in I don't know, 3 hours from now, we're going to do a live kind of office hours on the Saturday evening in The Hague, where we're going to broadcast it as well, and broadcast it on Meet again, and do a live kind of questions and answers session. During the Ubuntu Summit, we're going to have like a box where people can leave questions, and we'll also put a link online where people can leave questions. And the technical authors who are there for the recording, and other people who may be able to attend for the workshop on the Saturday evening, everyone's welcome. We'll kind of have a bit of a Q&A session between us. So if you want to think of your most awful and embarrassing questions to ask us and send them to us, I'd find that very funny. But today, we've got Shane is going to be doing a presentation on connecting recipes, algorithms, and documentation. And I skipped lunch today, so this is going to be good. Over to you, Shane.
Will I start sharing my screen?
Yeah, go for it. Go for it. If you have the permissions to do it. Yeah, you have.
Hope so.
Yeah.
Share. You can see this.
Perfect. It's beautifully rendered.
Excellent. So I'll start. So I'm going to be talking about recipes and software. And this is something, I guess, that we hear often when we talk about documentation, that one way of looking at documentation or thinking about specific kinds of documentation is to think of it as like a recipe. So in this presentation, I just want to explore that connection, and also how the recipe idea is often commonly used also in relation to algorithms. So what I want to achieve in this presentation is to kind of get myself thinking, but also to get everyone who's listening thinking about these kinds of connections, and whether they're real connections, whether when we make these connections, there's things that we miss that might be interesting to add. And I hope, as I said, that you'll learn something new, and you might hear some things that surprise you. So just to start, there's a few things that are going to recur, I guess, during the presentation. And one is the basic idea that this is a metaphor. So when someone says, for example, that a how-to guide in software documentation is a recipe, that's a metaphor. And a metaphor is something where we think of one thing in terms of another thing. And usually people construct metaphors when they're trying to explain or understand something that's unfamiliar. In this case, if, for example, you're just starting to work in documentation or in the software industry, the unfamiliar thing might be documentation, and the more familiar thing might be a recipe. So in order to understand the more complex, abstract concept of documentation, we might appeal to the idea of a recipe. The second thing that's going to come up a few times is the idea of ambiguity. And what I want to say is that recipes often work and are effective even when there is some ambiguities present. So for example, it's not uncommon in a recipe to see something like add salt to taste, which means something like add the amount of salt that you think is appropriate, or add the amount of salt that you think tastes good. So there's some ambiguity in the communication of certain necessary steps and ideas. And this is something that we might be very resistant to in software documentation, and there's often very good reasons for that. But I also think it's interesting to think about ambiguity in some cases as being a positive in the context of something like a recipe. Something else I want to talk about is the idea of something being effective. So this might seem obvious, but I think it's important to remember. A recipe could be perfectly written, and the recipe could always lead to the same outcome. So we could have a recipe that perfectly describes how to create something, but if the thing we create tastes terrible, it's probably not an effective recipe. So in something like a recipe, a key outcome is not just the material that we output as a result of the recipe, it's also whether someone actually enjoys the output. That's what ultimately makes a recipe a good recipe also. The last thing I want to talk about, or one of the last things I'll talk about, is just the idea of recipes as code. I don't think this is a term people use by any means, but I think just because of my unique background, I'm aware of lots of tools that have been developed and lots of concepts that have been developed around making recipes more like code that we would have in software. And you might not be aware or familiar with these tools, but I just wanted to highlight a few of them because I think they're very interesting. And also I think some of the ideas that are presented there could be things that we might want to take back into software documentation. And just a little bit about me. So I have a PhD in food science, and I spent a lot of my adult career working as an academic in food science. And I also, strangely enough, have a philosophy degree. So now I'm working in software, and this type of topic is exactly in my wheelhouse. So I know a little bit about food, and I know a little bit about software, and also my philosophy background makes me prone to speculate wildly about different ideas and topics. So on the screen, we have a bunch of different cookbooks, and these cookbooks are all relatively unconventional as cookbooks go. So on the top left, we have a very famous book by someone called McGee on food and cooking, and this is a very detailed encyclopedia of knowledge about everything you can imagine in food: vegetables, bread, beer, distilled spirits, jams, and it really tries to put the science in the explanations for how those different things work. At the bottom of the screen on the left, there's a green book, which is used in industrial food processing. So this book is targeted at people who are trying to create recipes for industrial scale food manufacture, for example. And in this type of book, you also have recipes, but the recipes tend to be quite a bit more precise than something you might find in a traditional cookbook, just by virtue of the fact that, just like in the software industry, in the food industry, people are concerned with things like consistency and scalability. So this is the kind of recipe book that people might not typically encounter, but it's important to think that there are other kinds of recipe books where we do have some of the same expectations around maybe precision that we might have for software documentation. On the far right of the screen, we've got some other interesting examples. at the top, we have the Raspberry Pi cookbook. Of course, this isn't about food; it's about a microcomputer. But it's interesting. It's interesting to see, and it's not uncommon to see the cookbook term invoked when we're talking about technical books in relation to software. And this tendency to talk about food examples and food ideas in software books is something we're going to see a few times during this presentation. At the bottom right of the screen, there's a book by The Domestic Godless, and this is a group of artists in Ireland. And this is an unusual recipe book. The outcome of the recipes in this book is not necessarily something that you would enjoy or something that might even be edible. So one of the recipes that's in front of me here from the book is cigarette ash and seaweed anti-cupcake. So the purpose of this book is to create recipes, I suppose, that are provocative and that make people think about food in a different way. So these are all different types of cookbooks that are related to food and how to prepare food, but they're different to the idea of the traditional recipe that we might be more familiar with. Here we have a more traditional type of recipe that we might expect to have, that we might see the usual structure of a recipe in. And these recipes are quite terse, so they don't waste a lot of space. They don't waste a lot of time on explanation. It's all basically describing the steps that are needed and the materials that are needed in order to produce this particular recipe. And one of the things I want to draw attention to in this particular recipe is the ambiguity that recurs, and this is not uncommon in recipes. So add a little salt. It doesn't say what exact amount of salt. Boil gently. You know, what does boil gently mean? Boil it for 5 or 6 minutes. So why 5 or 6? You know, why would you choose one or the other? Melt sufficient butter to just cover the bottom. So like how much is sufficient, what we mean by cover, and so on. Then at the bottom, we have another example of a recipe, which is actually from a scientific paper that I was involved in a number of years ago. And in this scientific paper, we were trying to create vegan cheeses from chickpea. So that was the focus of the study. And if you just glance at the method here, it's superficially similar to what we see in the traditional recipe above. So we see some steps, we see references to temperatures and different materials like butter again, but we do also tend to see a little bit more precision. So we see, you know, exact temperature values, exact RPM values for mixing, and so on and so forth. And this fragment is a fragment of a much bigger method, which goes into a lot of detail about, you know, how much materials we need to use and what ratios are used and so on. On the right, then, we have a fragment from the book on cooking by McGee that we saw earlier, and this is much more focused on explanation. So this explains some of, I guess, the scientific background as to how we might choose certain temperatures and conditions when we're cooking vegetables to avoid certain undesirable consequences. So this doesn't focus on giving us any step-by-step guidance on how to produce certain meals. It strictly focuses on explanations that might help us understand what's happening in the kitchen when we're preparing these meals. On this slide, what we see is an example of a very old recipe that someone from my family gave me when I said I was preparing this presentation. And the interesting thing about this is that we see that the person who owns the recipe has begun to customize it. So 1 teaspoon of orange extract is converted into 1 tablespoon. 4 tablespoons of grated orange rind is just deleted from one of the recipes. And we also have ideas here about substitutions. So at the bottom of the screen, we have cookie jar ginger snaps, and the original recipe suggests sifted flour, but the note that's added says we can also use xanthan gum, for example. and shortening is suggested can be replaced with butter. So there's an idea here that if we're creating a guide for some people, that the people might want to ultimately customize the guide or make it their own in some way, or take it forward in a different direction than we originally intended. But also, when we are deciding what the prerequisites are for someone to follow a specific recipe, that we might want to consider that certain materials might be substituted or could possibly be substituted. On the left of the screen here, we have another example of this. This is someone adding Weight Watchers points to a recipe. So the person who originally wrote the recipe, Susan Bonash from Minnesota, they didn't foresee probably that someone might be interested in Weight Watchers points, or think that that's something they might want to include. But the user of the documentation ultimately decided that this is important information for them to consider. On the right side of the screen, then there's another interesting example. This is a handwritten recipe, and if you look closely, it says, if you need more direction, call Steve's mom. So this is a local woman who obviously prepared the recipe, and what we see in this example is that there's an understanding that the knowledge that Steve's mom has about this recipe probably isn't completely captured in this documentation. If you want to really understand how to make this recipe, you might need to actually contact Steve's mom in order to produce the recipe in the best way possible. And just to relate this to some of the thinking that's happening in Canonical, then, I think most people in the call will have heard about Diátaxis, and this presentation isn't about Diátaxis, and I don't want to focus on it too much, but I do think it's important to mention this. The traditional recipes that we've encountered so far, we would understand in Diátaxis as how-to guides. So they're concise descriptions of actions that are necessary to achieve a certain result. These are guides that someone would periodically refer to in order to fulfill a specific goal. But they're not necessarily something that are designed to create a learning experience, for example. A learning experience in Canonical and following the Diátaxis framework is in the domain of tutorials. And here we've got a shot from an Irish newspaper where the journalist is describing how he taught his children how to cook, and he taught his children how to cook by explaining to them how they can prepare tomato sauce. So he was there as a guide with his children, explaining what was happening. The children were making observations as they cooked a meal, and through that process, they not only learned how to make a tomato sauce, they also learned the skill of cooking, and that skill then is something they can take forward into other cooking scenarios. And if you're interested in this, I encourage you to look at the official Diátaxis website, where there's actually a lot of food and cooking analogies that are used to explain concepts like tutorials and how-to guides and so on. And just to finish on the Diátaxis point, or to emphasize it further, an example of a how-to guide might be something like a step-by-step recipe for making a tomato sauce. And it has the steps you need to always produce a specific type of tomato sauce. A tutorial then, like I just described, would be something where the goal might be something beyond just making a specific thing. It might be learning the skills that are required in order to make that thing. A reference then usually it consists of descriptions of factual information. So here's an interesting example. All of the examples on this slide relate to sauce, just to keep things coherent. In French cooking, there's an idea of a mother sauce, and this is actually a type of sauce that is used as a base to create other sauces. So you can imagine that there's essentially a kind of tree, and at the top of the tree there's base sauces, and then from those base sauces we branch outwards into many different sauces, potentially hundreds. So here, for example, we see that tomato sauce, which we've been talking about so far, is a base for making things like marinara sauce. So a reference would be a good place for example, to have information like this, where we could list different types of sauces, but not just list them, also express structural relationships between them. And lastly, then, we have explanations. And this one here is quite technical. This is something that would be very familiar to me when I was doing science. It explains the physical property of viscosity, which people tend to refer to as the thickness of a sauce. And it explains in detail what this property is and how it affects things like sauces, but also how can we affect this physical property. And it says we can use things like starch, and what the starch does, the causal explanation for what it does, is it binds water and then the starch swells, and this impacts the viscosity. And not only that, it says that we can use starch, which is commonly available, but there's actually alternatives that we can also use that have a similar effect, such as carrageen and guar gum. So these are the 4 types of documentation that we hear about in Diátaxis. And what I want to emphasize here also is that these are connected. I think sometimes that's something that's missed when we talk about Diátaxis. And for example, here, when someone learns how to cook a tomato sauce, it could be very useful and very empowering for that person to subsequently read a reference where they realize that the thing that they have just made can actually be used as a raw material for making other things. In addition, if they subsequently read an explanation, and it doesn't have to happen in this order, but if they read an explanation where they find out how in detail to control a property like viscosity, then they can start to manipulate the properties of the sauce using starch and carrageen and guar gum in order to optimize the thing that they're producing. So I see all these things as being connected, and that the person who really masters cooking, for example, or any skill or task, usually embodies these 4 things. So on this point, I think it's important to mention that there's often levels or degrees of explanation and precision. And this is something that I've seen a lot looking at different types of cookbooks, some of which are more traditional and some of which are more scientific or technological. So one example I find really interesting in this area, which might be unfamiliar to many of you, is this pink tea product that originated in Kashmir, I think. And one of the important steps when you're making pink tea is you basically take green tea and you add baking soda to it. And this transforms the color from green into a really vibrant pink color. So at the top here of this diagram, we see the transformation from the green color to the pink color. And for most people who are following a traditional recipe for pink tea, all the information that they need is basically that they have to add the baking soda to the green tea and that this will produce the pink color. And to the extent to which that's a causal explanation, that's enough for most people. But when I was a teacher and I was trying to teach food science students how these things work, the explanation would have looked a little bit more detailed. So I would have said, for example, that we add the baking soda to the green tea. The green tea decreases the acidity of the tea. In other words, it alkalizes the tea. This results in a specific type of chemical effect, which is the ionization of certain groups associated with molecules called polyphenols. And when these modifications happen to the polyphenols, we get this pink color. And the biggest issue I had with students when I would try to teach these concepts was that they would say, basically, why are you wasting our time telling us this complex explanation for something when everyone is making this just knowing the top level explanation? Like, what possible advantage is there to having this deeper explanation, the kind of explanation that we expect in science? And the answer I always gave was that when you have this deeper level of explanation beyond just the how to prepare the pink tea, it gives you more power. It empowers you to do more things. And in this case, for example, baking soda is an alkalizing agent, so it decreases acidity. But baking soda contains sodium, and some people want to reduce the amount of sodium in their diet. So there's a question here: how can we achieve the same effect without using baking soda? And what we need to focus on is the deeper explanation, which is that we don't need baking soda, we need something that decreases acidity. And there's lots of things that will do that. So we could use potassium hydroxide, for example, which doesn't contain any sodium. And if we use potassium hydroxide, we can create the same pink color. And we can only modify the how-to guide or modify the steps or take a different path if we have the deeper explanation that can allow us to take that different course of action. So then on to software books. This is a quote from the start of a pretty famous book in software called The Little Schemer. So Scheme is a programming language of the functional variety. And The Little Schemer is a really interesting book that basically aims to teach you how to use the scheme programming language. And one of the interesting features of the book is that there's just a ton of food examples. So when they're creating functions and composing functions together with this programming language, they often take the examples take the form of food and cooking examples. Another interesting example here is from the UNIX programming environment, which is a book from the 80s that talks about scripting and file management and things like that on a Unix environment. And in one of the pages here, we have basically a file system and or a directory structure. And we see that there's a directory containing recipes, and there's two types of recipes here, pie and cookie. And if you look at the pie, it says it splits them into apple and crust. So they're using food here as a way to explain in a familiar way the idea of a directory structure to someone who may be unfamiliar with the Unix programming environment. And just something else interesting about this, which is that the example does encapsulate the idea that recipes can often be understood in using this tree-like data structure. And we're going to see this again in other examples. So here, for example, a pie consists of a filling and a crust. The filling can be apple or it can be raspberry. You can make the crust separately to making the filling, and then you combine them together to make the pie. So in this type of tree-like data structure, we encapsulate some facts about the recipe. These examples that I showed in the last few slides are somewhat superficial. They're using food to explain some basic concepts, like, for example, directory structures. But the recipe metaphor is often used in a much stronger way. And a really good example is from a very famous series of books from Donald Knuth, who's a famous computer scientist. And he wrote this series of books called The Art of Computer Programming. And in that book, he uses the metaphor of the recipe to explain what an algorithm is, which is obviously a really important concept in computing and in programming. And there's a kind of a popular set of properties that people say they expect of an algorithm. There's some different definitions, but the basic idea is that there's an input. There's at least there's 0 or more inputs. There's at least one output. The instructions that are described are exact, so there's minimal ambiguity, and that each step that's described in the algorithm is precise. The algorithm is finite, which means it stops at some point. It doesn't just run forever. It produces some output, and it also stops at some point. And lastly, that it's effective. So whoever is using this algorithm or program with the resources that are available, such as compute power, they should be able to run the algorithm, and it should be able to produce the outputs that we expect. So on the left-hand side of the screen here, I won't go into it, but this is just a very simple Python script I put together, which basically describes how we can think of recipes in terms of functions in a programming language. Individual steps are functions which take an input and return an output that's transformed in some way. And then we can compose the functions together in order to create more complex outputs. So this is the idea of looking at an algorithm like it's a recipe. So I just want to say at this point that this relationship isn't exactly one-to-one. It's not a perfect relationship, and some people will already be probably thinking that. So for example, I said in an algorithm we expect that the steps are described precisely with limited ambiguity. And this is the point usually where a computer science professor will start saying what they expect of their students when they're constructing an algorithm is usually something that's quite different from what they might expect from them if they were writing a kitchen recipe. So they will say, we can think of an algorithm like a recipe, but there are some properties of algorithms where there is a greater degree of expectation. And one of those things would be minimal ambiguity. Recipes in the kitchen are often written with quite a bit of ambiguity. So here on the screen, there's another metaphor, and we'll look at some other common metaphors in a sec, but a metaphor for love, for example, sometimes is war. So love is war, every day is a battle. And the reason I'm giving this example is that one of the troublesome properties of metaphors, and sometimes metaphors are very useful because they help us understand unfamiliar things. So if someone is in love for the first time and they're feeling confused and they're, I don't know, having some difficult days in their relationship, someone might say to them, well, love is a war, every day is a battle. But if you start thinking of love that way, it can become very troublesome for you. If you begin to think that, you know, the relationship you're in involves battles every day, then you kind of become trapped in what the metaphor has said about that reality. Another example would be saying, like, cooking is science. One must always be quantitative. So this is kind of something I would have heard a lot from food science professors, where they would say, well, cooking is science. And that's not true. You know, we can look at cooking scientifically. We can certainly attempt to understand cooking scientifically, but to say that cooking is science is untrue, or at the very least, it's metaphorical. And to try to, for example, teach the public or to teach a child that every time they cook, they need to do so with absolute quantitative precision might mean that you're doing a very bad job of teaching someone how to cook. So how-to guides are recipes. The output should be enjoyed. So that's a question. So if how-to guides are recipes, and if we take recipes to be something that produces enjoyment, obviously, which is something I would argue that they do, then that would suggest that maybe when we write a how-to guide for a software product, the person who follows the how-to guide at the end should get some sort of thrill or some sort of enjoyment from the how-to guide. And that depends on how we frame the metaphor. So I'm framing it differently than people typically do. Typically, people say, how-to guides are recipes. This means we have to specify them very precisely, and it should always yield the same output no matter who does it. But that's a very technical, cold description of a recipe. And I would say that when people who work on documentation use the recipe metaphor, what they're often talking about is something more like an algorithm, or the idea of an algorithm understood through that recipe metaphor. And this idea was encapsulated very nicely decades ago by a French philosopher named Gaston Bachelard, and he introduced this idea called the epistemological obstacle. So epistemology refers to anything related to knowledge or understanding. And he basically found, when he looked through the history of science and technology, that oftentimes there would be these periods where there was some sort of image or metaphor that was very prevalent and that people were basically trapped within, and they found it very difficult to escape it. And it meant that progress in things like science and technology would slow down. An interesting example that I remember just now is, for a long time, human digestion was understood as being a type of fermentation. And at the time, people had been fermenting things for a long time. So people had been making things like beer. And other people had recognized that if you provide some sort of agitation when you're fermenting beer, so you basically shake it up or mix it when it's fermenting, it would accelerate the fermentation process. So here, digestion started being understood as a type of fermentation, which isn't true, strictly speaking. And people knew that you could accelerate fermentation in beer by shaking. And at the same time, people realized that there was lots of babies who had digestion issues. So for a period, some people thought the best way to cure a baby who was suffering from some digestive issues was to shake the baby to accelerate the fermentation. So there was this image of digestion being a type of fermentation, and that affected how people understood digestion, but also how to solve the problem that babies had. And the solution that it suggested was actually a very dangerous solution and a very incorrect solution. Just to reiterate here, a metaphor is a partial mapping. So it's very easy to quickly determine that, you know, a recipe is not the exact same thing as software documentation. There are certain things like steps and materials and inputs and outputs that exist in both domains, but there are other things that don't. So for example, if you have a how-to guide in software, there's a possibility that there is an error that makes you, you know, completely exit the software system you're working in. But that's not something that necessarily maps directly onto a recipe, where you can typically recover from most mistakes that you make in the kitchen. Another interesting example might be, and these are just examples I'm tossing out, I'm sure there's more interesting examples than this, is cleanup. Like in software documentation, it's very common that there would be some explicit direction. For example, if you've installed a software package, there might be some explicit direction on how to uninstall that software package so you can clean up your system. Whereas in a recipe for making an apple pie, for example, it would be very unusual if someone said, okay, now you should clean your kitchen. And to clean your kitchen, you should take the things that you dirtied and put them into the sink and run water through them and so on. Typically, that would be excessive information, and we would assume more of the reader. So just on the outside here, I have some other examples. You know, the idea of ingredient substitutions, the idea of leftovers and what we might do with them, the idea of safety. So if you're talking about cooking meat, for example, in a recipe, it's responsible for the person creating that recipe to say that, you know, the meat should be cooked to a specific temperature because that's the temperature at which it's safe to eat. So safety is something that we should maybe expect in a recipe of that kind. But it's interesting to ask, you know, when we're writing software documentation, do we have the same expectation for safety? So by thinking more deeply about the metaphor, we can maybe begin to identify gaps and whether we should actually be enriching the metaphor we're using in order to push us in new directions with our documentation practice. One that I've referenced a few times here, or two of them that I've referenced a few times, are ambiguity and pleasure. So I would argue that in recipes, these are important features which serve some useful function, but they typically are not things that we include in our software documentation. Okay, so as a kind of introduction to the tooling that I referred to at the start, the tooling that's been used for making recipe creation more like software development, I wanted to refer to a newsletter that I did recently in my role in Canonical, and a newsletter related to this idea of tools for thought. And on this slide here, we have a chemical reaction, or a part of a chemical reaction. And the first term here, you don't have to understand at all. NaHCO3, this is our baking soda. And the baking soda here has been mixed with water, and it's producing sodium hydroxide and something else. So this is that effect I was talking about earlier, encapsulated on a single line using some symbols. And these symbols are really powerful in chemistry. It's not just a way of showing people facts. It's also something that scientists can play with. So scientists can easily manipulate symbols, come up with new potential arrangements of symbols, and this allows them to imagine new types of possibility. And I think for a lot of programmers, they think of programming that way. They're manipulating symbols, and through this simple act of manipulation, according to certain rules, they can create new possibilities, new worlds, new products, new industries, potentially. But these types of notation and symbol systems, like programming languages and chemical equations, these things had to be invented. They didn't just come from nowhere. They didn't always exist. And in the newsletter, I talked about how The symbols you see on the left here, which are these circles and stuff, this is an old way of representing chemicals, which was displaced by the method that you see on the right, which uses the letters. So in this slide, I just wanted to ask, what would a notation for software documentation look like? So if, for example, we were frequently writing documentation for things like creating virtual machines and connecting virtual machines with networking, how might we try to encapsulate some of those core ideas and relationships in a tight symbol system that would allow us to imagine new possibilities, but also to express these ideas in a very efficient manner? So now we're going to see some examples of where software developers start thinking about food, and it leads to some very interesting results. This article is one of the most interesting things I've found on the internet in recent years, and it's called Computerized Cooking, and it's written by a person called David Mundy. And I don't know much about this person, but this was copyrighted in 1985. And it's an incredibly interesting article that you can find online if you just Google it. And what it does basically, and I don't know if I can find the line, but it basically says that recipes are broken, that recipes don't work anymore, and that there needs to be a new way of preparing recipes. And then the author basically goes through a whole range of different styles of recipes. So he argues that, you know, there's something called the American Standard Style, and he describes it. And then he says that this style of recipe has a specific tree-like structure, which is something we saw earlier and we'll see again. And he relates this tree-like structure to the types that are studied in computer science. And then he uses this structure to begin to think about food in terms of software. So they're made up of three kinds of nodes, terminals, such as fish, which are operands or raw materials of the tree, unary operators, such as grind, which take one operand and yield one new operand. So this is clearly someone who knows a lot about software and programming, who then turns that knowledge towards the problem of recipes as he sees it. And what he does in this article is he basically lays the foundation for an entire programming language that he developed for describing recipes, an editor that he built for writing the recipes in, and so on and so forth in that direction. So this is someone who took the problem of recipes very seriously and began to apply their knowledge of software to the problem of recipes. A more recent example is a markup language called Cooklang. And the Cooklang markup language, it's written in a style that we see here on the left, and it produces an output like we see on the right. So at the top here, we have some metadata. So for example, total time 6 minutes. If I change this to 4, it will then update what we see on the right-hand side of the screen. But it also has a special syntax for identifying the semantics of a recipe. So for example, ingredients are symbolized by an @ symbol. So if I change apple juice here to pear juice, then we see the ingredient listing updated on the right-hand side. Equipment is symbolized by a hashtag. Quantities are symbolized inside curly braces. And what's produced on the back end is something called an abstract syntax tree, which programmers or computer science graduates might be familiar with who are listening. And this, again, is a tree-like representation of a recipe. So this way of representing recipes as trees is something that we see quite commonly. Another interesting example is this software called Recipe Grid, which you can find on GitHub. And this is basically a Python program that takes relatively plain text recipe description, and it converts it into a specific kind of diagram, which is really interesting. And the diagram basically shows us, again, another type of tree-like representation. So it says here, for example, that you take 6 tablespoons of cocoa powder, some golden syrup, butter, sugar. These are all heated. Then that material is mixed with these digestive biscuits, which are crushed. So it shows the kind of order of dependencies. So this material is first heated until it's mixed. This material is crushed before it's mixed. All the material that's mixed is then covered with this chocolate here that's melted. So again, it's a representation of a recipe in a tree-like manner. Another example from my science background was this effort to represent recipes using a very concise symbol system. And this suggested that we should actually describe recipes in terms of the phases of matter that are included in the food system. So we have G for gas, L for liquid, and S for solid. So for example, if we mixed gas into liquid, we get a foam. If we mix a liquid like oil with another liquid like water, we get an emulsion. And this leads to very concise descriptions of recipes. Like if you want to produce butter, you take an oil and water emulsion and you transform it into a water and oil emulsion. So oil and water emulsion will be something like cream. That means it's water with some oil droplets dispersed, and you would transform this into an oil which has water dispersed in it, which is basically what we have with something like butter. So these types of systems are abstractions from the reality of cooking, and these can be very useful. So for example, we can say whole milk butter and glossy paint that you might paint your house with. These are all emulsions. And this means then we can discuss all of these different things in the language of emulsions. We can understand them all by reference to some common features that they have. Similarly, we can say Python, Bash, and Perl are all scripting languages, so we can discuss and transform them as scripting languages. But sometimes this can go wrong. We can use a inappropriate level of abstraction. So we could say, for example, Docker containers, USB drives, and the div HTML element are all containers. So the div element, for example, is often referred to as the container element for HTML. We could say USB drive is a container in the sense that it contains information. But typically in a software context, especially in something like DevOps, if we're talking about containers, we're talking about a very specific thing. So when we use these new kinds of symbolic representations, we sometimes have to be careful about the context we're using them and their appropriateness. So I'll wrap up soon, but this is a quote from the poet Emily Dickinson. It says, "Tell all the truth, but tell it slant." And she was talking about poetry specifically. But this line, what it meant was that when you're communicating the truth to people, sometimes you shouldn't communicate it all at once. So if you're communicating the truth about war, for example, in a poem, you kind of have to space out some of that truth because it can be overwhelming or it can be difficult to read for people. And I would say sometimes that's true also of documentation. If we present all the technical facts all sandwiched together very condensedly, that can be overwhelming for people. So it's true that we have to represent our software as factually as possible and as descriptively as possible, but there's also something to be said for spacing out some of that terse factual language. And this, again, might be a place to introduce some ambiguity. On ambiguity, it's often referred to in a negative way. So if you're talking to someone who works in logic, they would say ambiguity is something that prevents us from understanding the truth. It's something that we have to fix in order to communicate clearly. In science, maybe a little bit more positively, if something is ambiguous, if we add the baking soda to the green tea and it produces a pink color, but we don't know why that happened, that can be a prompt for us to investigate. That can be something that fuels our search for the truth in that particular area. In other things like art and poetry, ambiguity can be a good thing because it can empower the person who's consuming that content to provide their own interpretation. Perhaps a little bit more controversial example is geopolitics. So you'll sometimes hear of countries who have a position of strategic ambiguity with reference to nuclear weapons, for example. So in all those cases, even though it's a strange combination of cases, ambiguity is something that's a tool that can be useful. And in cooking, we have lots of different examples of ambiguity as it's used in the description of how to do things. And this ambiguity is often an invitation for the person who's cooking to provide their own interpretation. So what's their idea of good? What's their favorite utensil to use? What's their favorite type of seasoning? And I think it's interesting to think in software documentation, is there similar invitations that we can offer, similar gaps that we can present to people where they can interpret things without, of course, breaking anything. So we want to be careful not to cause trouble for people, but also empowering them to make choices about the software that they're using or developing with. So just to close, the recipe analogy is very common. So if you're working in documentation, someone at some point is going to say a how-to guide is like a recipe, or a how-to guide is a recipe. And I don't think there's anything wrong with that. But I think what can be very useful is to really do some deep thinking about the connection between the recipe idea and the documentation idea. Because there are some things that we might be assuming in our documentation because of that metaphor that we're kind of imprisoned by to an extent. It also might present an opportunity if we identify things that we expect of a recipe, but that we're not necessarily capturing in documentation. Reflect on efforts to fix recipes. So this refers to software developers and programmers who have tried to fix recipes. And what I would ask you to do there is think, if recipes are broken, maybe we need to be careful about using it as an analogy or a metaphor for our documentation. At the same time, maybe the efforts to fix these recipes, which I would say are only popular amongst software engineers, maybe there's something misguided about that. Maybe they're missing something that's special about recipes because they're trying to think of them like algorithms. And maybe we don't want to do the same with documentation, because documentation isn't an algorithm either, even though sometimes we might think it is. Ask yourself, are there other analogies? Is there other analogies that might be better than the recipe analogy and that might push us in different interesting directions? Because if we get stuck with the same analogy and the same metaphor, we can begin to see everything like a recipe problem when maybe it's a different kind of problem. Okay, that's everything.
Wow. Thank you so much, Shane. That was amazing. I really, really enjoyed it. Lots of these I've enjoyed, but that's really close to being one of my favorites. The weird thing is I have two sets of books on my desk. One of them is Knuth's programming, and the other one is The Complete Works of Emily Dickinson. And that's the two things. So we should share the books on our desks one time.
Yeah.
We've nearly run out of time.
I'm sorry I took so much time.
No.
I was over ambitious. That was too much time to be talking. It
was definitely worth it. If anybody wants to ask a quick question, then you're more than welcome to. You have to be quick, Bill.
Yep. So one of the things that people keep saying to me is the difference between programming and everything else is that English would not be a good programming language because it uses imprecise terms that have precise meanings.
Mm-hmm.
Whereas programming languages have precise terms that have precise meanings. So it's the ambiguity that makes it difficult to translate other analogies to programming.
Yep. And it's interesting to think, I think when you're working in documentation, sometimes you look at programming languages as the model, or as the model of effective communication. But we communicate effectively all the time with ambiguity. And sometimes ambiguity is interesting. But of course, if someone is working on a critical piece of software for an enterprise, you got to be careful about the way you use ambiguity if you're going to do that.
I'm also going to say that if anybody has questions they'd like outside of the scope of this meeting, put them on the forum or put them on the comments to the video when I put it online, and we'll try and ask them. We'll ask Shane next weekend when we do the live recording.
Yeah, that'd be great.
Simon said, "I love the multidisciplinary approach to the presentation, Shane." Yeah, thanks. It was very deep and very thought-provoking. I think I'm going to have to watch the video again. It really fascinating. Really seems to have hit. I knew that your background was food technology, but seeing it presented like that, especially, you know, the documentation aspect and the similarities and the cooking as code, is really fascinating. I have to get my head around it.
Well, Graham, when I used to talk this way in academia, people used to say, "What the hell is he talking about?"
Well, you found your place. With that,
and I'll try to put the slides online eventually. and maybe we can link to them, and I'll try to do a better job of referencing the things I'm including as well.
Or maybe some of those old family recipes. They look great.
Yeah, I was planning this, and I was like, I'm going to rely heavily on the Internet Archive, and then it went down. So I was talking to my partner. I was like, does anyone in your family have old interesting recipes over in America? So they sent them over to me.
Yeah, brilliant. Well, thank you, Shane, and thank you all of you for attending. It's been really good fun. We'll see you a week on Saturday for the live. It's going to be a couple of weeks maybe of it being a bit unpredictable, but we'll be back to normal in a few weeks. So hopefully see you then. Thank you all again, and see you soon.